Hello everyone, this is Manohar Reddy, Assistant Professor, Department of Cybersecurity, Institute of Aeronautical Engineering. In the last sessions, we discussed about different database softwares, different database models, different architectural components of database, and different database languages. So today we are going to discuss the next topic, acid properties in DBMS. Acid properties in DBMS. So acid properties are very important in the transaction point of view. Every day we are doing different types of transactions like banking transactions, financial transactions, online transactions, e-commerce transactions. Everywhere and anywhere we can do a different transactional operations. So to do that all the transactional operations, we are going to know about these acid properties. Based on these acid properties, we are knowing that the transaction operation is success or not. So depending upon the failures, depending upon the success, we are going to know that the transaction was successful or otherwise a transaction was failure. So because of all these things, we are going to know about acid properties. So see here, acid properties. So DBMS is the management of data. We already know that. So managing of all the data by using a different database softwares. So different database softwares are designed and developed by the companies for their own requirements. So here also DBMS is the management of data that should be remain integrated when any changes are done in it. So whenever we are doing some changes on the database itself, it should be maintained integrity. It is because if the integrity of the data is affected, whole data will get disturbed and corrupted. So if integrity of the database will be affected, that means if any loss will occur, integrity loss will occur, then the data will get disturbed or corrupted. That means the data may be modified or the data may be corrupted and data may be disturbed. You are doing some changes on the database. So that's why the data will get affected or disturbed. So to maintain that integrity of the data, to achieving the independency of the data, we are going to know about all the properties. There are 4 properties described in the DBMS or database management system, which are known as acid properties. So the main purpose of knowing that acid properties is to achieve the data independency, to achieve the integrity of the database. So there are 4 acid properties. Acid stands for atomicity, consistency, isolation and durability. A for atomicity, C for consistency, I for isolation and D for durability. These all the properties we are doing in the regular transactions of credit or debit transactions or online transactions or financial transactions or banking transactions. Anywhere we have to follow all the properties. So we'll see what is meant by atomicity property, what is meant by consistency property, and what is meant by isolation property, durability property. We'll let you know one by one. So first one is what? Atomicity property. So the term atomicity defines the data remains unique. That means the data should be unique. There is no duplicates or there is no other data copies. That should be remains unique. So it means if any operation is performed on the data, either it should be performed or executed completely or should not be executed at all. So that means if any operation is performed on the data, that operation should be completed. Then only the data will not get any loss. As well as the data should be unique. It further means that the operation should not break in between or execute partially. That means the operation should not be breaking. The operation should not be break, or the data may not be lost because of doing this property. And in the case of executing the operations on the transactions, so suppose you are doing any credit or debit transactions, you are doing that execution of that transactions, the operation should be completely executed and not partially. The operations, sometimes the operations may be completed successfully, sometimes the operation is not successfully completed, not completed. So at that time, this atomicity property, this atomicity reason is failure or atomicity property is satisfied, we'll see. So suppose we'll take the example, if Remo has account A having $30 in his account, from which he wishes to send $10 to some other account. So suppose A having $30 rupees and he wish to transfer $hero account $10. So he wants to transfer 10 rupees from his $30 amount. So which is B. So here is the B account. In B account, the sum of $100 is already present. So already $B having some 100 rupees. Now he wants to transfer 10 rupees to B account. So A having 30 rupees and B having 100 rupees. Now A wants to send 10 rupees to B account. Then the B account sum will be $110. $110. Because the 10 rupees is transferred to the B account. There will be two operations that will take place. Whenever you are doing that credit or debit transactions, the two operations will take place here. One is the amount of $10 that Remo wants to transfer will be debited. So if he wants to transfer 10 rupees means here indirectly performing debit operation. Indirectly performing debit operation. And from here $B account holder, he having credit operation. He having credit operation. So here the transactional operations, debit and the credit operations are performed. So if these two operations performed, if it satisfies, if the amount has been successfully transferred to the B account, then atomicity property satisfied. Then atomicity property satisfied. See here, from his account, and the same amount will be credited into account B into hero account. So now what happens? The first operation of debit, executes successfully, but the credit operation, however, fails. Sometimes the credit operation may not be fail. Sometimes the credit operation may be fail. So by seeing this diagram, you will get to understand all the things. So this is the A account holder. This is the B account holder. So before transferring 10 rupees, A account having 30 rupees. A having 30 rupees and B having 100 rupees, right? So he wants to transfer, A wants to transfer 10 rupees to this B account. A wants to transfer 10 rupees to B account. Now the available balance is 20 rupees at A account holder, right? So whenever you are doing this transaction, so a transaction is nothing but what? A transaction is nothing but a single operation, a single atomic operation or single operation. You can say that a unit of operation. A transaction is nothing but a unit of operation, a unit of operation. So here you are doing two operations called debit as well as credit. Debit as well as credit. So debit from A account holder and credit from B account holder. A wants to debit 10 rupees to B account holder and B wants to credit 10 rupees from A account holder. So whenever you are doing this you are doing these operations, automatically we'll see here debit 10 rupees. So 10 rupees will be debited from A account, but it should not be reached to the B account holders. It not be credited to the B account holder. So transfer process is not yet completed. So from A account holder side debited is successfully, but B account side is credited failure. B account holder credited failure. So partial execution. So no atomicity execution. no atomicity will happen. So that means atomicity property is not satisfied. Atomicity property is not satisfied. So here what we said, atomicity is nothing but the data should be remains unique. The data should be remains unique. So whenever you are doing operation, credit operation or debit operation from both sides, it should be unique. If he wants to perform debit, this side is unique, but if he wants to perform credit, but this side is not unique. So that's why atomicity property is not satisfied here. But we'll see in the next step what will happen. In this diagram, we already seen that 10 rupees is debited from A account and it is not credited to B account. Suppose you can see you can do these operations at particular some time. After some time, you are going to perform these two transactions again. You are going to perform these two transactions after some time. So what will happen? We'll see. So before transferring, you are having 30 rupees, and when you perform debit of 10 rupees, it should be debited from A account holder and it should be transferred to the B account holder. So credited. So the debited amount 10 rupees is credited to the B account. Now the available balance is what? $110. So here the amount of before transferring is 30 rupees. After transferring, available balance is 20 rupees. Similarly here, the before 100 rupees, after crediting 10 rupees, you will be having 110 amount. So debited successfully from A side and credited successfully from B side. That means the two transactional operations successfully executed at the two receiver sides, at the two sides. One is sender side as well as receiver side. So you can say that sender sends data successfully to the receiver side, and the receiver also say that the received data is successfully received at the receiver side. So complete execution, atomicity execution is successfully. So we can say that if the operation is not at all successfully completed, then you can say that atomicity property is not satisfied. If the two operations were successfully executed, successfully completed, then you can say that atomicity property is satisfied. This atomicity property we already seen in the regular basis in the ATM machines also. When you are taking some amount by inserting card, at the some time your amount has been debited, but your amount is not getting to take, right? So at that time this atomicity property fails. Later they will check and update the details, then they will give the chance to again deposit your money into your account, right? So this is the way you can understand the atomicity property. So if those two operations, credit and debit operations, performed successfully, then you can say that atomicity property is satisfied. If the two operations are not satisfied, if any of the operation is not satisfied properly, then you can say that it is not satisfied atomicity property. Right? So this is the first property in the asset properties and the transactional operations. And next one is what? Consistency. The word consistency means that the value should remain preserved always. That means the integrity of the data should be maintained. So in the atomicity property, you are going to remind the data should be unique. But in the consistency property, you are going to remind the data should be integrity. That means integrity is nothing but transparency, or you can say that it is a complete uniqueness property. So which means if a change in the database is made, it should remain preserved always. So that never lost integrity of the data. So in the case of transactions, the integrity of the data is very essential, so that the database remains consistent before and after the transactions. So when you are performing credit or debit operations, before debiting what the amount you have and after crediting what the amount you have, that data should be maintained as a integrity. So that itself indirectly you can say that consistency property, it is satisfying. See in this example. So A having 300 rupees and he wants to perform operations with B and C. A account holder having 300 rupees and he wants to perform operations with B account and C account holders, right? We'll see how it will happen and what the consistency property should remains, and it shows that integrity is not having any problems. We'll see. So A account holder having 300 rupees and he wants to debit 50 rupees to B account holder. He wants to transfer or debit 50 rupees to B account holder. So now the available balance is what? 250 rupees. 250 rupees because he transferred 50 rupees to B account holder, right? So now the having amount is 250 rupees. Again he wants to debit 20 rupees to the C account holder. C account holder. So after debiting 20 rupees from A account holder, what will have? 230 rupees he will have. So now debiting 50 rupees to the B account holder as well as debiting 20 rupees to the C account holder. Debiting 50 rupees to the B account holder and debiting 20 rupees to the C account holder. He at a time he wants to performing two debit operations simultaneously. He wants to perform two debit operations simultaneously. So one is debiting 50 rupees and the second one is debiting 20 rupees to the C account holder. So what will happen? So before B account holder, before crediting 50 rupees, he will have 100 rupees. And after crediting 50 rupees is there. After crediting, the available balance is what? 150 rupees. So the data is maintaining a unique as well as consistent manner, because the data amount debited from A account is always remains same and crediting amount from B account holder remains same. So whatever, there is no errors, there is no partial executions. So completely it takes two operations to be successfully executed. In the same way from A to C account holder also. So before C account holder having 50 rupees, after crediting 20 rupees, he'll having 70 rupees. He'll having 70 rupees. So from the A account holder to C account holder also, there is no partial executions or there is no errors or there is no failures in the transactions during these two operational performance. So see here, this is the way you can understand the consistency property. So whenever you are doing debit operations, credit operations for the multiple account holders, B and C account holders, the data should be maintained as integrity. That means after performing debit or credit operations also, the data should remains unique. So the data should be maintained as integrity. Now you can say that it is a consistency satisfied. So performing these two operations for the two account holders maintains consistency property is satisfied. Sometimes you will get the losses of transferring the amount. So A transferring 10 rupees to B account is success, but A transferring 20 rupees to C account is maybe failure sometimes. At that time, the data is not maintained integrity. So that you can say that data is not maintaining consistency. Consistency property is not satisfied. So this is the way you can perform. So atomicity property you can perform in the maintain of data should be remain unique, and in consistency property you can maintain the data is integrity after doing the transactional operations to the multiple account holders. So this is the way you can understand from the consistency property. And the next one is isolation property. So the term isolation means separation. That means you are doing individual transactions or individual account holders with the transactions. So we'll see. In DBMS, isolation is the property of database where no data should affect the other one and may occur concurrently. That means if you are performing operation on one database, that will not get affected to the next another database. That will not get any affected to the another database. So we'll see. The operation on one database should begin when the operation on the first database gets complete. So one database operation should begin when the first database gets complete. It means if two operations are being performed on two different databases, they may not affect the value of one another. So they may not having effect on one value to another value. So that means when you are doing the same transactions or two transactions for the multiple purpose, multiple persons also, that will not get any affected, that will not get any affected from one to another. So each and every transactional operation should be separated. So this one debit operation is separated, credit operation is separated. So in the case of transactions, when two or more transactions occur simultaneously, the consistency should remain maintained. So integrity should be maintained as well as uniqueness should be maintained. So any changes that occur in any particular transaction will not be seen by other transaction until the change is not committed in the memory. So until the database transactions are committed, until and unless the database transactions are not committed, the values in the database is not get same, not get successfully stored, not get successfully stored. So we'll see. So this is the A account, and this is the B account, and this is the C account. And the A account to performing transactional one operation to the B account, and performing transactional operation to the C account transactional 2. We'll see. So the before value, before transactional performance, before operations, the A value is having 100 rupees and debiting 20 rupees to the B account, debiting 20 rupees to the B account, and available what? 80 rupees. And similarly debiting 20 rupees to the C account, and the available balance is what? 60 rupees. That means when you are performing a debit operation with multiple persons, multiple account holders, that data should be remains the same, that data should be remains the same, and the data should not get affected from one to another, when you are transferring amount from A to B, and C will not get any affected. And similarly when you are transferring A amount A to C, B will not get any affected, So that data, when you are performing transactional, the data will not get any affected from individual operations. So that's why you can say that transactional operations or isolation property is satisfied. That if any data will get affected, then you can say that isolation property is not at all satisfied. So here when you are performing a credit or debit transaction with the B, performing debit or credit transaction with the C, the two B and C account holders will not get any affected from individual databases. So now we can say that it is isolation property satisfied, right? And the last one is what? Durability property. So durability ensures that the permanency of something. So if you are doing transactional operations, so when you are doing the transaction, you will say that first of all begin transaction, then next process transaction, and last end transaction. So begin transaction one operation, processing transaction second operation, and ending transaction third operation. During this all the transactional operations, transactional operations should be satisfied atomicity property. It should satisfy atomicity property. That means data should be unique. And the second one is what? Consistency property. It should be maintained integrity, data integrity. And isolation. It should be satisfied isolation. That means separation of the data. When you are doing the transactional operations, if all the atomicity property, consistency property, and isolated property satisfied, then you can say that durability of the transaction is satisfied. See here, the term durability ensures that data after the successful execution of the operation becomes permanent in the database. After doing all the transactions, the database will be committed. To save permanently. So to saving permanently the database, we are going to perform commit operation. commit operation. So the durability of the data should be so perfect that even if the system fails or leads to crash, so after performing commit operation, if any system fails or crash, then you will get a recover of the data. You will get recover of the data. Until and unless you will not get committed of the database, you are not going to get back your data. You are not going to get recover of your data. So to recover the data, you should committed. You should committed after all the transactional operations performed. After all the transactional operations performed, you can proceed with the commit operation. So the commit operation is used to roll back your data or get back your data. Roll back your data or get back your data if any system fails or leads to a crash. So the database still survives. So however, if it gets lost, it becomes the responsibility of the recovery manager for ensuring the durability of the database. So the durability of the database means what? So if any problems will occur in the system or any transactional operations, the data will get recovered. The data will be get recovered. So then only you can say that durability of the property should satisfied. If you are not going to get a recover of the data, that is not satisfying this durability property. So for that we are going to commit the database after all the transactional operations performed. After all the transactional operations performed. So that's why you can mention here the command must be used every time we make changes. We are doing changes every time, right? So by doing that all the changes we are committing the command so that all the database should be saved permanently, and if any system fails or crashes, then we will get the recovery of the data. We'll get the recovery of the data. So these are all the transactional operations, or you can say that acid properties in database management system. So these are all the acid properties. We are observing that you are doing the transactional operations in the banking sector, financial sector, loan sector, anywhere, right? So this is all about acid properties. And along with this topic, we'll see the differences between a delete, truncate, drop commands. Delete, truncate, drop commands. So we are doing the transactions. Some of the values will be stored, some of the values will be deleted, some of the values will be dropped. So what is the difference between that delete, drop and truncate? We'll see. So delete command is a DML command. So delete is nothing but manipulation purpose. So we are deleting means indirectly we are manipulating the data. So that's why you can say that it is a DML command. And a drop command is DDL command, data definition language command. And a truncate also DDL command. And delete, it is used to delete the rows or records based on the conditions. Based on the conditions, you can specify with the where clause. So if you want to delete a particular row or particular name, you can use this where clause and deleting that particular record. While coming to the drop, it is used to delete the entire table along with its schema and structure. So it is deleting the schema and structure of the data entirely deleted. But here truncate, it is used to delete the entire records of a table. Table will not be deleted, but the records of the table will be deleted without affecting the schema of the table. Without affecting the schema of the table. So if the where clause is not specified with conditions, it details all the records of the tables will be deleted. So that means if you are not specifying the where clause in the delete option, the delete operation, indirectly you are doing the deleting all the records. Indirectly you are doing deleting all the records. So if you are specifying means you are specifying that record means you are going to delete particular record only. So in the drop command there is no where clause. In the drop command there is no where clause. And the truncate also there is no where clause. And in DML command, as a result, the operation could not be rolled back. The operation could not be rolled back. We are not get, after deleting the record, we are not going to get back the data. We are not going to get back the data. And drop, it is a DDL command. As a result, the changes cannot be rolled back or undone. So it is also, we are not going to be rolled back again. And it is a truncate, it is a DDL command. As a result, the changes cannot be rolled back or undone. rollback the undone. So these three operations you are not going to get back. Because of we are doing the commit operation only, we will get back the data, right? So delete, it scans every row before deleting, make it slower and time consuming. So it is going to check each and every record. When you are specifying the record to be deleted, it is going to be check each and every row, then it will delete the which you are going to delete the record. After checking all the records only, it will be deleting your record. And drop command, it is faster and time saving. It is not going to scan each and every record, and it is going to delete complete table, drop table name, like that. And truncate, it is faster than the delete execution because it does not scan every row before deleting all the records. So it is also taking some fast deleting, and it is not going to be scan each and every row. So this is all the differences, and you can see the syntax wise difference also here. So delete with where clause and without where clause. So when you want to, suppose you will have like student table. Suppose you will have a student table. This is the table student, and student table contains student name and student ID. And student name is what? Some Raj, Rani, and Sam. So suppose this having three names, and the student ID is 2, 3, 4. So this is the table, and you can perform delete or drop or truncate operation on this table. So what will happen? Suppose if you are performing with where clause, so I want to delete a record of Raj. I want to delete a record of Raj. So only I want to delete Raj. Then how you are specifying with the delete operation? With the where clause. So delete from table name what? Student, where student ID equals to 2. So delete from table name is what? Student, where student ID equals to what? 2. Student ID equals to what? 2. Then after doing this operation, what will happen? The Raj records will be deleted. And remaining other two records will be safe. The other two records will be safe. Suppose if you want to delete without specifying where clause, delete from table student, then all the student table will be, all the records will be deleted. All the records will be deleted as well as the table will be deleted. But when you are performing truncate with no where clause, so truncate table name, table name is what? Student. So then the values records in the table will be deleted, and the schema is not get affected. Of this student. So records will be deleted, but table will not be deleted. And last, drop table name. Drop table name is what? Student. Then it will drop all the entire table. Along with the schema also. Along with the schema or instance, you can say that. It will be deleted complete table. Or complete schema of the table. So this is the way we can understand the differences between delete and truncate and drop. So this is all about the ACID properties along with the transactional operations you are performing on the regular basis. So we'll see what we discussed in this session. So first of all, ACID properties. So ACID properties, we are having ACID properties in the transactional operations. The transactional operations are successful, then atomicity property or consistency property or isolation property is satisfied. If any transactional operations are failure, so atomicity property may not be satisfied, or consistency property may not be satisfied, or isolation property may not be satisfied. So like the way we can understand the transactional operations in the real time oriented. So these all the ACID properties will be regularly we'll see on the transactional operations, like taking the mini statements, crediting the amounts, debiting the amounts, doing the changes all the in the databases, all databases. So these are all the ACID properties, and along with the ACID properties, the operations, delete operations, drop operations, and truncate operations. This is all about the ACID properties and differences between delete, truncate, drop commands. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.